Ever pondered the unique strengths that Rust and F# bring to the programming table? These two languages, each crafted with distinct philosophies and goals, illuminate fascinating aspects of modern software development. Dive into the world of Rust first. Born out of a project by Graydon Hoare in 2006, Rust is a brainchild of Mozilla Research. It aims to provide memory safety without using a garbage collector. Rust's design centers around concepts like ownership, lifetimes, and borrowing, which help developers manage memory safely and efficiently. The language prides itself on its performance, rivaling that of C++, and on its reliability, which makes it a favorite for systems-level programming. Features such as zero-cost abstractions, move semantics, and error handling via the result type not only prevent crashes but also eliminate data races. Switching gears, F# emerges from a different lineage. Developed by Microsoft Research in the mid-2000s, F# is a member of the ML family of languages and draws heavily from OCaml. It's primarily a functional programming language, but supports object-oriented and procedural programming. F# shines with its succinct, robust, and expressive syntax. It integrates well with the .NET ecosystem, making it a superb choice for enterprise applications. Features like type inference, immutability by default, and pattern matching streamline complex calculations and data processing tasks, fostering clearer and more reliable code. When comparing Rust and F#, the distinctions become clear. Rust's stringent compile time checks ensure utmost performance and safety, making it ideal for system-level applications, embedded systems, and anywhere performance is critical. On the other hand, F# offers a more flexible environment, conducive to rapid development cycles, especially effective in areas like analytical software, financial models, and enterprise applications, where productivity and correctness are crucial. In conclusion, Rust offers unparalleled control and performance for low-level tasks, where safety and efficiency are paramount. F#, with its elegant syntax and functional-first approach, excels in scenarios that demand quick iterations and high-level abstract thinking. Both languages have carved out niches where they not only survive but thrive, demonstrating that the right tool for the job is always dependent on the task at hand.